Welcome to qnawire.
Okay, in this problem we have an electron orbiting a hydrogen atom, and we're going to use the Bohr model for the n equals 1 ground state. We're going to apply the Heisenberg uncertainty principle to find the uncertainty in this electron's momentum, given that its uncertainty in its position is equal to the Bohr radius for this first state, the n equals 1 level. So the equations we'll be using the Bohr model twice. We'll be using the radius of the electron at different energy levels, according to that model, and the momentum at different energy levels. We're going to be using n equals 1 for both cases. And of course, we're going to apply the Heisenberg uncertainty principle. So we have many constants we need to be using, namely a naught, the Bohr radius, Planck's constant, h, and then the electrical permittivity of free space, and mass and charge of an electron. So let's jump into it. So to start, we can find the radius of this electron, R1. This is in the n equals 1 energy level. So our n squared will be 1, and so we simply have the Bohr radius. So it's nothing too interesting. It'll be 5.29 times 10 to the negative 11 meters. We're going to call this our delta x, our uncertainty in position. So now we can apply the Heisenberg uncertainty principle, solving for uncertainty in momentum. Plugging in some simple numbers, we get a result of about 1.99 times 10 to the negative 24 kilograms meters per second. So how does this uncertainty in momentum compare to the momentum of the first energy level? So P1 is simply going to be me squared over 2 epsilon naught h. Normally there's an n to the negative 1 here, but we plugged n equals 1 in. So we're left with this big fraction of different constants. When we plug all the constants in very carefully, we will end up with a result of 1.99 e to the negative 24 kilogram meters per second. So interestingly, the predicted uncertainty in momentum for this electron is actually equal to its actual momentum in this particular energy state. And that's the main result that we're interested in.